Thank you for joining the Once Changing the World, which is India's first Future Tech Meets Sustainability podcast. And today I'm delighted and honored to have with me Dr. Mayank Kejriwal, who is a research assistant professor in the Department of Industrial and Systems Engineering and a research lead at the USC Information Sciences Institute. Dr. Kejriwal's research focus is on knowledge graphs, and he has co-authored an MIT Press textbook on knowledge graph. He's also the co-author of domain-specific knowledge graphs construction. Dr. Kejriwal's work has been funded by DARPA, industry, and by private endowments. And the topic of discussion is obviously going to be knowledge graphs and the significance in the artificial intelligence research, plus artificial general intelligence. So, Doctor, really appreciate you taking time and being part of the podcast. Why don't we start with a small background in your works in the field of AI?
Sure. So I have been interested in AI since I watched Star Trek back when I was in middle school. So, specifically in most of the Star Trek series, you have the Star Trek computer, right? And so you can talk to the computer and it does amazing things. It can almost read your mind. It can, it can just, be like a human being, really. And so that was my first experience with AI. And when I was going through undergrad, grad school, etc., the vision really narrowed, a little bit, because you focus on an area of research and these grand visions, we think are 50 years, 100 years in the future. And now here we are in 2023, where something like the Star Trek computer is on the horizon, I would say. And no one would have thought, even like 5 years ago, that it would be on the horizon. So this is a really exciting time to be in AI. And so, it's really been quite a journey and we don't know what's coming.
Yeah, I think we're sitting at the cusp of time where we really don't know what's coming, because technology is converging and the rate of the way its acceleration, it's both awesome as well as scary. And you rightfully pointed out that we are transitioning into the world where science fiction is becoming science fact. So your research, your expertise is knowledge graph. Would you be able to explain what knowledge graph is and its role in artificial intelligence?
Sure. So actually, before we even get into knowledge graphs, we should focus on knowledge, right? Because that underpins knowledge graph. So intelligence, as we understand it, comprises, 4 components. So there's reasoning, learning, planning, and knowledge. And the way that this diagram was drawn is that there's reasoning, learning, planning, and they are like ovals, they are operating on the knowledge. So the knowledge underlies all of these things. And, we can understand that, right? Because knowledge really underpins, everything else that we really do. So if we want to have intelligence in machines, then we also need to give knowledge to machines. And so knowledge graphs is really just a way of doing that. So it's one of several ways, but it has turned out to be a very good way, especially when you have large amounts of data and the data could be noisy in some sense, coming from different sources. So, in those kind of situations, which is the norm at this present moment, representing knowledge in a graph form is what we might think at a high level as knowledge graph, but the goal really is to give knowledge to machines, to allow machines to have access to facts, entities, relations, attributes, events, all kinds of things that then enable the reasoning, the learning, the planning, and finally the intelligence.
When you say representing knowledge into machines, how do you go about doing that? What's the process? And once you do that, what are the applications?
So let's try to define what a graph is, right? So, these are not the high school graphs that we remember, which were the functions that you plot X versus Y, etc. This is the graph that looks more like a network. So a graph is, a set of nodes and edges, that is the definition. It kind of looks like a network. And the intuition behind representing knowledge in this way is that entities, so entities would be things, it's like I am an entity, USC is an entity, this podcast is an entity, and, and so on and so forth. So entities are these things that usually have names, right? So anything that you can give a name to, you can think of an entity, although there are entities that don't have names as well. But, let's restrict to named entities, right? Which is a huge class of things in the world. And so entities are the building blocks of the knowledge graph. So you can think of entities as nodes, but there are two additional things that go into knowledge graph. So one is that entities have attributes, right? So, I am a professor. So my profession is, a professor. My affiliation is USC. My date of birth is something. My gender is something, etc. So I have these attributes that are properties that describe me in some sense, right? So attributes are sort of, you can almost think of them as meta information about entities. So an entity has this meta information, and that's attributes. And then you can also have relations between entities, right? So, let's say USC is an entity and Mayank is an entity, and Mayank works for USC. So there's an edge between Mayank and USC. The edge has a label because it doesn't make sense to just draw an edge. What does it mean? In this case, it's something like works for. And the edge also has a direction because USC does not work for Mayank. Mayank works for USC, right? So there's a direction. So when you start putting all these things together, you have entities, directed labeled edges, and you have attributes. And now, if you do this at scale, right? So now you have millions of entities, hundreds of millions of edges, attributes, etc. Then, it's a pretty good representation of the world, right? If you think about the factual content of what we know, it can be represented in that way. Now, the nice thing about doing that, once you represent it as a graph, is that all kinds of graph machine learning can be applied to that. So, for example, let's say that I know some things about an entity, but I don't know everything. But if I look at the whole graph, so, let's say that I like action movies, or my friends like action movies, but you don't know what kind of movies I like. So that's like the recommender problem, right? But if you know who my friends are, and you also see that my friends like action movies, then you might guess with some probability, right? This is a very simple example that I might like action movies, and so on and so forth, right? Similarly, political affiliation, the other things, we know that there's a lot of, homophily, so to speak, where you make friends with people who are really like you, more often than not. And that's like one example. There are many others, right? So if I co-author a paper with someone, there might be reason to believe that that person also works for USC, etc. Now, the graph machine learning has become very powerful. By using the deep learning on these big knowledge graphs, we can very accurately predict information that we have not directly observed. So not only do you have this initial knowledge graph, but now you can expand the knowledge graph using graph machine learning. And anytime, the applications all range from things like recommender systems to answering questions, right? So when you have a system where you ask a question to the machine, then the machine can go and query the knowledge graph and give you the answer. We're also seeing large language models like ChatGPT now, addressing that problem. But the problem with large language models is that they can hallucinate, they make things up. So you still need, for high critical domains like medicine, government, defense, and so on, you still need that knowledge. You want to be sure of the answer. You don't just want to take the risk that 10% of the time a large language model might be making the answer up and doesn't know what it's talking about. So, that's kind of, where it falls. And we have addressed applications ranging from healthcare to fighting human trafficking, to social media analysis even, and so on. So any application where there's a lot of data and you need to do inference over the data, you can use knowledge graphs.
How cool is that? So you're saying through knowledge graphs, the machine kind of understands the relationship between a data. And can you explain the point, when he says that, ChatGPT, these large language models, the underlying tech behind there is transformer models. How does that differ from knowledge graph? And are you saying that if you leverage knowledge graph within these transformer-based LLMs, would they stop hallucinating and the answers would be better? Are you suggesting that?
So the field of knowledge graphs, it really came from search, interestingly enough. So just like we are now seeing, large language models, Microsoft and OpenAI and so on, 12 years ago, Google had come out with the Google Knowledge Graph. And they had announced a Google Knowledge Graph through a blog post. And the title of the blog post was Things, Not Strings. And that actually goes to the heart of this issue. So if you think about search, right, when you type let's say places to visit Los Angeles, right? Um, what would happen before, like, 15 years ago, is that there would be some string matching, like you would take this query and you would match it against documents. There would be some very shallow pattern matching, string matching, and you would get a list of web pages, that are ranked in order of the string matching. But this is very unsatisfactory because we want the search engine to understand that we are asking for tourist locations or places to visit, and that Los Angeles is not just a string, it's a city. So with the Google Knowledge Graph, what ended up happening was that now, because of the knowledge graph that Google has, it's able to recognize that Los Angeles is a city and that places to visit is a set of tourist locations. And so in the graph world, this is kind of easy to represent. So the Los Angeles is a node in the knowledge graph. And the set of places that we are looking for are also nodes, but those nodes are linked to Los Angeles through, let's say, tourist location, a relationship called tourist location, right? So the trick is that, okay, do we have the knowledge that Google does? And can you go from the natural language query to the knowledge graph, to the graph world? And that also it's kind of perfected for a large set of queries. So indeed, it is able to understand in a way, in a very real sense, by using the knowledge graph, it can understand what you're asking for. And the consequence is that if you search for something like this now in Google, or even 10 years ago, you would see the list of places at the top of the web page. You'll see the little image with the place mentioned below it. And there would be like a list of places right at the top of the screen. On the side, you would see something about Los Angeles. We would call it a knowledge panel. You would see what other cities are related to Los Angeles, what else is being searched for. You would even see a hotel recommendation. So all this stuff that is kind of at the side, you can almost think of it like a frame. And then, around the list of web pages. So we would just have the list of web pages before, but now we have this frame. And this frame is coming from the knowledge graph. And the beauty of this is that now you don't even have to click on a web page. For many queries, you just know the answer when you type it in, and you don't even need to actually go to the web pages, search for things, make a list, and do those kinds of things. So it's really made us a lot more productive. Now, coming to the large language models, we are again seeing, unsurprisingly, that the battleground is search. A lot of people, don't notice that. They think that there are all these grand applications, but I can tell you that the first sort of battleground, if you will, is always search. It's big business. And even today, despite all the great things that Google is doing, much of its revenue still comes from search. That is its main business. And, Microsoft, I think, has some, fraction of that. It's non-trivial, but obviously it wants to increase its fraction because it really is big business. And, there are other companies on the horizon that are looking to append in that, disrupt in that space as well. Everyone ultimately has to do a good job with search, whether it's YouTube, whether it's Amazon, whether, whatever it is. In some cases, it's domain specific search. It is not generic search, but it is search. If you don't do a good job with search, you won't be able to let the customer find what they are looking for. And very quickly, your advertisement and all those things will collapse if a competitor comes along. So search is big business. The knowledge graph came up in the search world. And the large language models are also looking to disrupt search. This is why all these big tech companies are heavily invested, especially the web-facing one, right? We hear about Google and Microsoft the most in the large language model race. We don't hear as much about Amazon and Apple, although they are also working on it. But they have less of a threat from this business because, of course, Apple is hardware, Amazon is e-commerce, third-party marketplace, etc. So yes, they are working on these things, but they have less to lose, if you will, than Google and Microsoft from losing in this large language model race. So with the large language models, if you now type in the natural language query, the large language model can answer your question without resorting to a knowledge graph or some kind of data structure. But there is a risk that it might be making something up. And there have been many documented instances of this. The most egregious case that I can think of, which is in the courts actually right now, if I'm not mistaken, is that there was some large language model. I don't remember which company, and I obviously don't want to guess, but it was some large language model. And apparently it made something up about the mayor or some political figure. and said that individual had been criminally indicted or was under criminal investigation, something like that, something really, that is not good for politics. And that person, I think, is now suing for defamation. So we're still in the space, and companies are actually being very careful, I would say. They don't want to be liable. They want to tread carefully because there are legal consequences to making things up. And there is an argument that has been made by some of the pioneers of deep neural networks that hallucination might be unavoidable, that because of the deep kind of nature of these models and hundreds of billions of parameters that are in these models, so far, no one has figured out a foolproof way to avoid hallucinations. Now, if ultimately your answer is coming from a large language model, the knowledge graph will not help because the answer is coming from the large language model, not from the knowledge graph. But what we are exploring right now in our group, and this is really cutting edge work, is that we want to use the large language model to query the knowledge graph. So typically when you query the knowledge graph, you need to know the language, think of it like SQL, like almost like SQL. Like if you're in the database world, you would need to know SQL to access the database. With knowledge graphs, it's not dissimilar. There's kind of a language that you have to learn depending on which infrastructure you're using, which graph database you're using. And it's really complicated, and normal people cannot really, use those languages. It's kind of like asking someone to learn programming, right? Not everyone can do that. So what we are thinking is that you would enter the natural language question, like a long question, but instead of directly getting the LLM to answer your question, the LLM would go to the knowledge graph and would ask the knowledge graph that this is my understanding of what the user is asking. And so I am querying you and you give me the answer because we know we can trust your knowledge. Once you get the answer, I will massage it and make it look natural and give it back to the user. So we're almost looking at the LLM like a translator, if you will, like an intermediary that is sitting between the knowledge graph and the user. And that's the line of work that we are exploring right now. So that's like one way in which you can combine the two. And there are other ways in which this kind of thing is also being explored. How do we combine LLM with other technologies so that we can get the best of both worlds? We get the power of the LLM, we get the robustness, the conversational ability, because you can converse with the LLM in a way you cannot with any other technology. But the knowledge we really want, if we want like high bounds, good bounds and constraints on the knowledge, then we are like, let's not trust the knowledge inside the LLM because it gets 90% correct, but 10% of the time it can go woefully wrong and we have no way of making out when it goes wrong, and we just can't afford that. So that's kind of where the field is sitting right now. Now next month it could all change completely and there may be new technologies coming out. But right now, this is where the field is.
So thank you for explaining so nicely. And I hope, wish you the very best. And I hope that the AI hallucination problem is correct, because that is genuinely a huge problem. Knowledge graphs. Now, when I was going through your profile, it has lots of applications across e-commerce, retail, crisis response, human trafficking, and you also mentioned about social media analysis. Could you start with maybe retail, and then maybe we could get into human trafficking?
Sure. So for e-commerce, actually, it was one of the very first applications, I would argue, after the web search, where knowledge graphs were applied. And I think the best model for that I can point to is Amazon. So Amazon has this thing called the Amazon Product Graph. I don't know its current status, but it was a huge effort. And what they had done was that they had built what looked like a knowledge graph from the data they have, right? And they do have a lot of very good data of, multimodal data, text descriptions of products, reviews, who's buying, and there's back-end information that we don't have access to, obviously, but they do, what the sales are, and, when you go to a product, and then, which other product you click on, etc. So there's this huge body of information that can be represented in a graph form. And again, what happens is that when you search for something, you want the search engine to understand what you're searching for and what the meaning, what the intent is behind your query, as opposed to just string matching, right? And so by having the product graph, they are able to do that. they are able to better understand the consumer and match what the consumer wants with the products that they have. So that is actually that's a very good example. eBay also had a knowledge graph. So, again, the core idea is that you have entities, these are things you can purchase, but also other things that are relevant to e-commerce, sellers, etc. Entities have a lot of attributes. A t-shirt has a color, a size, etc. These are attributes. And there are relations between them, right? Like if I buy a red t-shirt, then what else am I going to buy? And so there's kind of a relationship over there. There's a relationship between the manufacturer of the t-shirt and the t-shirt, right? And then the manufacturer is making other things and so on. So it's a very natural graph format. The alternative would be that you have this very complicated database, and then you can't do graph machine learning, you can't do other things on it. So when you have a large amount of data, right, it makes absolute sense to represent it in a graph format and then to also build a search engine on top of it. So that's kind of what's happened in the e-commerce space. With that. Now into the more non-profit space with something like human trafficking. So we had this project back in 2016 when I joined USC. The project began, I would say, in 2014, so 2 years before I joined, and it ended in 2018. So I was there for the last 2 or 3 years of that project. And the project was funded by DARPA. It was called DARPA MEMEX. And just to tell your audience a little bit about DARPA, because not everyone has heard of it, it's a very interesting organization. It stands for the Defense Advanced Research Projects Agency. So that's a complicated name, but it's basically within the US Department of Defense. And it's this high risk, high reward funder of research. And it was created after Sputnik. So back in the 60s, when Sputnik happened and the US got jittery about that because they were like, the Russians are the first to send this thing into space and we are falling behind and so on. So that was that fear, right? This was the Cold War and so on. So they decided to create this fast moving agency, where low bureaucracy, these projects that only last 4 or 5 years, 4 years usually or fewer, and they're high risk, high reward. They fully understand that the project might fail and that may not succeed. But the idea is that once in a while, with some percentage, the project will succeed. When it succeeds, it will eventually end up changing the world. And this is not an exaggeration. The original internet, what we now know as the internet, was called ARPANET back in the 60s and 70s. So DARPA is the inventor of the internet. Then came the web in the 90s. But the internet is really based on ARPANET. DARPA has created technologies like that underlie at this point things like Siri. The technology behind Siri came out of DARPA, DARPA funded effort, basically. There are numerous other things. We are working on things like artificial general intelligence, which involves problems that are being funded by DARPA right now. So this project, right, was this is like some background to kind of tell you what kinds of projects you're interested in. They are not interested in low-level problems. They really like big problems, moonshot problems, as they would call them. And so this program was called DARPA MEMEX. And MEMEX is actually the name of an instrument that was conceived back in the 1940s by Vannevar Bush. So Vannevar Bush was this bureaucrat, in a way, who was very heavily involved in the US government. He was one of the founders of the National Science Foundation, which funds a lot of the fundamental research in the US, scientific research across all areas, pretty much. And he had at the time, so remember, this was in the 40s, before the smartphone, before all of these things. And he conceived of this device. He called it an intimate supplement to memory. That would be this device that you would have with you and would learn from you, would be like a memory. It would be like a supplement to your memory. It's like an extension of your brain. And it contains everything. It's recording everything that you're doing. It contains all your knowledge, all your information, everything. And it's kind of like almost like an extension of you. Well, today we have the smartphone. Right. And that is kind of like that, a little bit like that, but not as far as Bush would have liked, as he suggested. So what MEMEX tried to do was to go that extra step. What they wanted was what they call domain-specific search. So their core idea was, imagine a law enforcement investigator. They use human trafficking as the example application. So they were like, okay, imagine you're law enforcement and you want to build a Google kind of search engine for your domain. So you know about the domain, what's important in the domain, what the important websites are, what the important concepts are, what you're looking for, what kinds of questions you want to ask the search engine. But you cannot ask that to Google because, let's say that someone has gone missing and you have reason to believe they're being trafficked. And usually trafficking would then happen online. Their image would be posted online. Their other thing would be posted online. So you have some physical description, where they were seen last, right? And what you really want is to put that into a search engine and see that, okay, are there any advertisements, right? Sex advertisements out there that resemble this? And if there are, then show me, right, what those advertisements are and what the phone numbers are in those advertisements, because there's usually a phone number. It's a physical business, right? You can reach the, provider, right, through the internet, but ultimately there's a phone number and it's physical. It's like location based, right? Like whoever the individual customer is, they have to go to the location, and because of the nature of this thing, right? It's very physical. So it's a really dark domain, by the way. One of the things that I learned when I was kind of in that domain, sort of engineering, in a way, was I got to talk to a lot of law enforcement and meet law enforcement. They became my friends. I even got to talk to human trafficking victims. I talked to social scientists. I was even invited to Geneva, where I went inside the UN. I didn't present before them, but I was inside the UN. And also the UN General Assembly in New York and so on. So it's kind of, I've really had very privileged experiences getting to know this domain a little bit more in depth than I could have imagined when I came into it. It's a very dark domain, and there's tremendous potential for technology to really make an impact. And so and it's kind of shocking, really, all over the world, how primitive the technology is, that law enforcement has, I would say, and that nonprofits have, and that governments have. I mean, everywhere, what I would say is that except for a few pockets, like maybe the Department of Defense or an intelligence agency or Interpol or some, those agencies, they are probably at the forefront of technology, and they have to use the latest technologies and so on to catch the bad guys. But there are many organizations, including local law enforcement, local NGOs, that are trying to help these victims. State governments, governments in developing countries, Philippines, India, Middle Eastern countries, etc., that really don't have the technology and that don't have the resources to pay for the technology. I mean, their resources are better spent elsewhere. Right? They are very limited resources. So that was what we were trying to do. We wanted to give them technology that was free, that was easy to use, and that would help them to solve the problem. And that's kind of, what we built had this knowledge graph underlying it. But the knowledge graph was a very small part of the problem. I don't want to exaggerate its importance for this problem. It was very important to what we were doing, but it was only a part of the problem. It was, this is like one of those problems where any technology you come up with is only going to be a very small piece of the puzzle, because you need all hands on deck to crack the problem at all. So, it was rewarding, but also at the same time, it also made us realize, how much further we still have to go to, not maybe even just solve, but to make the world a better place, a little bit better.
When you talk about AI, at least when it comes to in the media, you actually just see AI being used in enterprise, AI being used in social media, and so on and so forth. You don't see its applications which is spread across, in situations such as this, like which is law enforcement and human trafficking, and actually working for good. And you mentioned that knowledge graph possibly is one part of it, but this convergence of technology is giving us like really real world application which can be used across for good. But also there is this, in the course of conversation, you were mentioning that how potent it is, where if it goes to the wrong side, we can go into a world which is surveillance tech, where anybody at any point in time can be located. And so yes, and in the beginning of the conversation, you mentioning about, how science fiction is becoming science fact. AI currently still is in its narrow space. It can do a specific task very, very good, exceptionally better than the world's brightest mind. But it still doesn't have general purpose knowledge like how we humans have, And then besides our general purpose knowledge, there's something called as consciousness, which we still haven't kind of figured out. But then, yes, there is a race of developing machines with general purpose knowledge. You spoke about artificial general intelligence in your work with DARPA. Can you elaborate on that? Maybe first, explain to the audience what artificial general intelligence is, and would it require to also have consciousness, or it could just have general purpose knowledge? That would be really nice.
Those are great questions. So first, I want to push back a little bit on what you just said, that AI is still very narrow. I think that this was true 1 year ago, but I really do believe that the LLMs, we cannot claim that anymore. And I don't say that out of a sense of hype. I think that most people would tell you that that is, in a way, what has changed. Like if you ask an AI researcher that why do you think it has changed so much? It's the reason why it's not an incremental technology or even a slight leap in performance is because we really do believe that this is the year which will mark the period of ANI, artificial narrow intelligence. I think we see that coming to its apex and then its close last year, and I think that this year is arguably the first year perhaps when we can really start to think about AGI very seriously. So I think that ANI, I would push back that we just have ANI and we don't have AGI. We don't have AGI, but we do have general purpose knowledge. I think that the LLMs really do have general purpose knowledge. They are able to do amazing things. They can answer all kinds of questions about things that you wouldn't believe that they know about. They can, write poems. They can, do all kinds of things. It's arguable whether they're as good as humans or how derivative are they. But you can also make that claim for humans. When you see a human artist or you listen to a song, who is truly original, right? You listen to a song these days, it sounds like a song, not just these days, most songs, right? You look at 50 years of songs, there are very few songs, right, that are really original. There's very little art that is truly original. Every writer is not Rabindranath Tagore or, so on, right? There are many, many derivative novelists, and they are really picking up on what worked before and they want to sell books. So we can't really say, AI, it's doing this and it's derivative and this and that, right? That doesn't fly because humans also like that. Debates in a way. Most AI researchers also don't believe that AGI has arrived yet. We think it will arrive, and it's on the horizon. It's only a matter of when, not if, I think. I think that's what most people believe, that it used to be a question of if. Like if you had asked me this last year, I would have said it's still a question of if, and we don't know, 2050, 2080, 2040. But now there are lots of people saying, and they're saying it seriously, that by 2030 we could have AGI. So, and they may not be wrong. I think that there's very good reason to believe that by 2030 there really could be AGI. The time horizon has narrowed. So, what do we mean by AGI? So the best way I can describe it is there's ANI, there's AGI, and there's ASI. So ANI is narrow intelligence, artificial narrow. The A stands for artificial in all cases, and I is intelligence. ANI is artificial narrow intelligence. And this is exactly as you were saying, it's very narrow, it's specialized. There's an AI that does face recognition very well. There's an AI that plays a game very well. There's an AI that can do that can do recommenders very well, movie recommendation, etc. So lots and lots of ANI. And indeed, because of deep learning and the deep learning revolution, I would say like 10 years ago, the ANI became really good. So individual ANIs became very, very good and superhuman in some cases. And the deep mind is sort of the emblematic, paradigmatic example of this, where they use deep learning and reinforcement learning to show that you can really have super intelligence in some narrow domains, games, etc. And then you have AGI, which is AI that is more human-like in its ability. It can do several things at once, just like a human can. So there's one architecture that can do all of that. It can answer questions. It has common sense reasoning. It can recommend. It can write poetry. It can translate languages. It can do all kinds of things at once. And language is very central to this. So there's also physical reasoning. We are less focused on that. I think that is where development has been less, to build robots that have the physical, sense of touch and the same kind of reasoning that these large language models do. So physical embodied AI has been harder to achieve, much harder. and we're still far from that. But the language only, where you just access to AI using language, that has come along very far. And it's not just language. There's already, I think, if it's not already here, it will be here very, very soon, probably within the year, where you can also access using images, videos. Like you can just, the ChatGPT like system will not just be ChatGPT. You can give it images. You can ask it to generate images. So it's combining all these things. There used to be a image generator, which is DALL-E or Stable Diffusion. There's the large language model, which is text. There are other models like Amazon came out with one, Meta's come out with one that can deal with speech, that can deal with voice. But now I can assure you it is less than 6 months away where all of these will be in one model. So, think about what that means, right? The AI can be talking to you. It can be singing to you. It can be drawing things for you. It can be understanding what you're drawing. It can be answering questions and having conversations with you. I mean, that is getting closer to AGI. And we have to remember, this is the beginning, not the end. We are less than 1 year from ChatGPT's release. New models are on the horizon. Bigger models are on the horizon. This is year 1. So think about what's going to happen in year 7, year 9. Do we really know what's going to happen? I'm not so sure. There's an exponential progress. So suddenly, conversations about the singularity, about AGI, are not so far-fetched anymore. We all used to think they were far-fetched. Many of us thought they were far-fetched and that it's really very speculative and even irresponsible in a way. But now we're like, this could be happening very soon. This is on the horizon. I mean, it's going to, we can argue about, it's going to hallucinate 5% of the time. And sometimes it makes silly mistakes and it's not quite human-like in this way and that way, but it's really, cutting corners. It's the fabric of it, the bulk of it is very, very good. It's very sound. It does very well. And that's why everyone is working to incorporate it in applications, architectures. There's a big push going on all across the board to incorporate this technology because it really is very good. I mean, people are not foolish. They're not going to throw money if it's not good. Right. So everyone across the board is looking to incorporate this one way or the other into their pipelines, down the line, 5 to 10 years down the line. So we're seeing profound changes. I mean, software engineering could go completely out of fashion. I would not be surprised if 6 years from now, there are no software engineers, or for every 10 software engineers, there's one software engineer. We are already seeing the signs of that. There are some of my students, they come to me, they're like, no one seems to be hiring. It's so difficult now to get a job in one of these companies. And just 5 years ago, they were like scrambling. I remember when I was a PhD student, Google Research came at the time to my campus at UT Austin, University of Texas at Austin. And they had these big, they had these parties with swag and, with, very nice locations. They would give gift bags. They would do all these things. Their researchers would come, 4 or 5 researchers, to talk to the CS department, to figure out how they can get PhD students to come in as interns, to work for them. And they were really courting us, in a big way. That's what they were trying to do. They wanted academics to come and do research and not join academia and so on. And now it's kind of the tide has turned a little bit. Now they can pick and choose. And now like master's students are not getting jobs. They have to get a PhD because that's what companies want now, etc. And so on. So the world is changing very quickly. Now, ASI, which is artificial superintelligence, of course, that one, we're not talking about that now. But it's not really a super leap from AGI. If we achieve AGI, ASI would only be a few years away. And we already have ASI in narrow domains. So it's not unlikely that as this convergence happens, that the ASI will also become a very real possibility. Of course, it's kind of frightening in some sense. It's possible to hype it, etc. But it's also possible to have a rational conversation about it. The truth is, there's a lot of unknowns out there about this. Now, to speak to consciousness, it's very coincidental that you brought that up because actually on Sunday, I'm speaking at a symposium which is called the Math of Neuroscience Symposium. And in that, they are exploring the issue of consciousness, quite actively. And I'm actually giving a talk where I have a set of slides that literally is asking the question that is AGI necessary for, or is consciousness necessary for AGI, and why or why not? And my claim in the slides is that they are independent. that there's a connection between them, but they are independent. And the reason is that this is not human general intelligence. We are talking about artificial general intelligence. And so because it's artificial, I'm not so sure that consciousness is even definable for it. I think that the first thing that needs to happen is we need a scientific definition of consciousness. And we don't really have that. We don't understand that in humans. I've spoken to consciousness, people who are interested in consciousness. I've had long conversations with them over the last year, and they seem very divided. I mean, even within their own community, if you ask them, they all have different views. There are some people who think insects have consciousness and all life forms have consciousness, trees have consciousness. There are others who don't go that far. I tend not to look towards that space a lot because I think that it's non-objective. That doesn't mean it's not important. I think it's very important. But from a neuroscience perspective, we can certainly come up with what it means to be conscious. Perhaps we might be able to agree, and maybe neuroscientists do, on what it means to be conscious for a human. So I'm not saying it's impossible. There's an objective way, perhaps, to do that. I'm not familiar with the neuroscience enough to say that it is, but I do know from conversation that it might be that they would be willing to come to a consensus once they collect enough data and if enough of them got together on this topic. But what does it mean for us to observe an AI, right? To light up, and there's no brain here. When we run inputs through a large language model, the whole system really lights up in a way. The processing that is going on, it's not really like a brain. That is a convenient analogy, but it's not like a brain. It's all neurons. We call it neurons, but they're not like real neurons. They are for those of us who know the field, they don't look like anything like a real brain. It is totally different. It's inspired by the brain, but that's why the analogy stops. So what does it mean, right, for a mathematical or computational entity like that to have consciousness? It's easy to speculate. I don't think there's any objective consensus on that. So I stay away from that. I think it's interesting and I think about it and I entertain when someone comes and talks to me about it. In my mind, I'm like, I'm not going to lose sleep over it. So
fair enough. And so what I'm hearing from you is that we are at the cusp of artificial general intelligence, and these multimodal models could be those pathways or a specific architecture which would lead us to, and we staring at. In fact, Ray Kurzweil has always predicted that 2029, 2030 is the time frame when we would get to artificial general intelligence, and I think that Twitter is abuzz crazily because there are so many researchers writing like papers back to back, and then just recently I think Sam Altman just tweeted which said that AGI has been achieved internally, and then he backtracked saying that it's just memeing. So maybe share your thoughts.
This is not the first time. I should just add. Right. This is not the first time that people in industry have made crazy claims like that and have had to walk it back. Right. I mean, the last year, or maybe it was this year, because it's all moving so quickly. There was a paper called Sparks. It has the phrase "Sparks of AGI." I think there was a Microsoft researcher that might have been involved. I don't remember, but it's on archive, and it was widely panned. I mean, the paper came out, and so many people panned it because they were like, "Look, this is like, what are you saying here, right? Like, we're reading the paper. This is like the claim that the Google engineer made that the Google system is sentient." Right. And all of that. It's like these kind of crazy claims, right, which don't really help in a way. And so I wish sometimes that these entrepreneurs and these individuals would stop for a moment and be like, we're doing something great here. Let's not blow it up. They are doing something great. No one is denying that. But let's not blow it up by then, going into the territory of the bizarre in a way. So right. There's a line between where you're doing something great and then you go into bizarre.
Yeah, I completely agree because I think, media picks it up in a way and hypes it up in a fashion where the general public starts thinking about it from like a scene from a Hollywood movie, because I think the general public always perceives AI as, iRobot and the sentient robots running amok, or
not always. No. But let me push back on that as well. Yeah. So that is the common trope that they always perceive it like that. That's how the media likes to present it. But I have spoken to many people in the last 5 months, where they have played with ChatGPT, because many people have played with ChatGPT, right? It's very easy to play with. So just 3 or 4 weeks ago, I was in a salon. They call it a salon. It's like an evening event, and there were people from different professions that attended, copywriters, marketers, artists, and so on. And it's very interesting, all of them had played with ChatGPT. And in fact, many of them were very skeptical, which scared me. Well, not scared me, which gave me a sense of foreboding, because some of them were like, well, like there was a marketer, she said that I played with it and I'm not worried. I don't think it's going to take away my job. It could not, it gave this thing which was really not that good, and so on and so forth. And then before I could say anything, someone else was like, well, but how hard did you try, right? And so sure, did not get it right the first time, but if you try 4 or 5 times and you prompt engineer a little bit, and if you know how to do that, and this was like actually a different artist who was saying that I actually prompt engineered around DALI, and I got a really good poster for this event. And she had come up with this really amazing poster for the salon that got a lot of traction. And she generated it using DALI. And so when I asked her, how did you get that? She was like, I had to prompt engineer a lot. Like initially I put in a prompt and it didn't give me what I wanted. And then I kind of played with it. I added things, I removed things. And eventually I got exactly what I wanted. And it's better than what I would have wanted, actually. So the model gave me what I wanted, or better than what I wanted, once I played with it enough. So I think that, in fact, the bigger danger, if I may, is not that the technology will be super hyped up, etc., because already people are, governments, etc., who don't understand the technology are already leaping on that bandwagon and saying we need regulation, we need this and that. So I'm not too worried about that. I think the real problem is that people might be underestimating the potential of the technology, and that never has good consequences. If you underestimate it, you won't be ready when the technology does come and disrupt, and the disruption happens quickly. It is usually it takes a little bit of time for the disruption to fully, it's kind of like there's a fixed cost. You're building a factory, but it's going to take a year maybe for the factory to be built. And then suddenly things are rolling off the conveyor belt en masse, right? And I think that's the best analogy for this kind of disruption, where initially you don't see, everyone's talking about it. And for a year or two, you don't necessarily see like huge changes in the way that the market operates. And then all of a suddenly what you find is that instead of 10 software engineers, there's only one software engineer. And instead of, a business manager, there's this and there's that, and a computer has replaced this process, and a computer has replaced that process. And it all happens, within a very quick span of time. And, that's what the history has shown, that once it's there, it disrupts quickly, because certainly in capitalist markets, everyone is scrambling to have that edge and they need to move quickly. So I think my fear is that people may not be ready enough for this technology. Again, we have to remember this is year one, right? So these debates about whether AGI is here or not, when will AGI be here, when will ASI be here, these are kind of interesting debates in a way, but it doesn't have to be that extreme, right? Like, regardless of whether AGI will come or not, or when will it come, and what does AGI mean? By the way, we still don't know what a true definition of AGI is, similar to consciousness. We just agree that it has to be human-like, but how human-like? Do we need embodied cognition where you have a robot? You must have a physical entity. It must have this and that. All of those things are up for grabs. Some people are like, we can have AGI without a physical body, and that makes absolute sense, and so on. But I'm saying, we can argue about the definitions all we want, and we can argue about when this will come and when that will come. But it's kind of, every single year, you're going to see these technologies, gradually taking over, and then very quickly taking over a lot of jobs and a lot of people's occupations. And they're not, in these Western countries, in the US, UK, in a lot of capitalist countries, that your job is not protected. You could be out of a job tomorrow, like the way that the Google engineers found that out. It wasn't because of the large language model, but a lot of these companies are overhired during the pandemic. And so that's the scene, the image was actually quite shocking. I don't know if you saw it. There was a long line of workers that were outside Google headquarters with boxes in their hands. And some of them had literally just been fired a day, 2 days. I mean, there was very short notice. Maybe even if it's a month or two, that's very short notice. But at very short notice, there was this long line, 12,000 workers or something like that, you would think it's like a food picket line or something that's what it looked like. A lot of people commented on that it's looking like like one of those lines where people are trying to get bread, literally, and it was a little bit like that. It was quite shocking. I mean, probably any one of those people, if you pick them out from the lineup of 12,000 or whatever number of workers were laid off, probably had a super high IQ, went to very good schools, I'm sure, got top grades, can program on the back of their hand, can do all kinds of things, and it's they were out, and it's that was not the only company where that happened. And on the grapevine, what I'm hearing is that it is very difficult for a lot of them to find employment again. Some of them were even fine, but many of them could not. Many were international students. They had to come back. This is something that is not very widely reported on, but the statistics are very clear. So many Indians, Chinese students, their green card was an application. It takes a long time when you're in industry, and the quota is very low for every year. And you're on a work visa, and now you're suddenly out. And the rule is you have to find work within like 60 days or something like that. It's a very small period. And if you don't, then you go back, and I don't think your green card application is there anymore. It gets canceled, because if you're not there, you're not working, it can get canceled. So it was really, I mean, it's when you see all of that, right? These are like white collar workers. These are software engineers, data scientists. They were told Harvard Business Review, data scientist is the sexiest job of the 21st century. That was literally the byline, the title in the Harvard Business Review article, a decade or two ago. Everyone was saying, go learn how to code, go learn how to code. You have a high paying job if you learn how to code, and this and that. And now we're on this horizon where that may just become obsolete. A big chunk of that may become obsolete. So there will be unrest. I have no doubts about that. I don't say this with any pleasure. There will be unrest.
Right.
There will be violence even. Right. I suspect there will be violence in the same way that there was in the early days of the Industrial Revolution.
Right.
And that's not something that I think we are ready for.
So what I'm hearing from you is that we've been underestimating these technologies, and it's growing at a rapid pace. And we need to come together and find answers for the solution, because you're saying that in the next few years, this whole hype around, at least here in India, that, the coding is the future, could just be out of wiped out. We won't, because all the parents over here, I mean, at least here in India, I mean, because everybody is looking up to Elon Musk and the techies, because they've turned into the rock stars. Earlier it was the music and the actors were the rock stars, but now people like Elon Musk and Mark Zuckerberg are becoming the rock star, because that's you're socially, financially, really cool, if you become a techie. So all the parents are pushing their kids to become coders and stuff like that. But you're saying that in the next few years, and I think even Imad Mathak from Stability AI has been saying the same thing, that coding is going to be redundant. So I think governments needs to come together and take cognizance of not just artificial intelligence. I'm vested deeply into metaverse.
Our governments, including the US government, don't know anything about technology. And I really mean that. I mean, it's funny, you see these videos sometimes from the US Senate, and it's no better, I think, in most other places in the world, actually, where they have no idea like what an app is. They don't know. I mean, they literally don't know. Like it's kind of cringy, I think probably my parents have much better understanding of technology than some of these government officials do. So they don't understand technology. They are taking a very, old-fashioned kind of approach to it, thinking that it can be regulated and this and that. And it's not going to work really. I mean, regulation doesn't work with technology, actually. You can try to regulate it, but once the genie is out of the bottle, it's going to percolate. There's very little you can do. You can try to place some guardrails around it. You can't stop it. By the way, speaking of coding, right? I mean, I can tell you that I asked my student to go and actually build an entire system using ChatGPT. And this was a system that it had taken her 3 weeks. She's a PhD student initially, right? So this is a system she had built. So she knew what the system should look like, what it should do. She was able to build the entire system from scratch using ChatGPT in 4 hours. 3 weeks of a PhD student's effort and really smart student knows the technology. With ChatGPT, 4 hours. That's what we're talking about.
Yeah. So
Again,
I think
year one. This is
yeah,
year one.
exactly. So
Year one, 4 hours. We've gone from 4 weeks to 4 hours.
right. So I really hope that the government, society, institutions comes together, because like I was pointing out, I mean, it's not just AI, this convergence of technologies, like metaverse, Web3, AI, and possibly in the next, maybe the decade, quantum computing. I think it's going to completely disrupt humanity. And I think we live in a capitalistic world where no matter how much we say AI pause and stuff like that, nothing's going to pause, because I think we've always look for the nations are running to get the best tech, so they get an advantage over the other, because that's how the capitalistic system works. So you spoke to the AI automation bit, and then there's people like Eliza Yudkowsky who talks about existential threat. There's Elon Musk, Stephen Hawking used to talk about that. So Can you talk about the existential threat, and what are there ways to mitigate this problem?
So I don't believe there's an existential threat. And it's interesting to me that the people who seem to have talked about it as an existential threat were not really computer scientists, right? So Stephen Hawking was one. Bill Gates kind of mentioned it, but I haven't heard him mention it in a while now, perhaps because his alma mater, Microsoft, right, is heavily investing in the so-called technology that will lead to an existential threat. There's no existential threat here. This is a new technology. The only existential threat, if anything, we have humans to fear, which we have always feared. There could always be a tyrant who goes and does something and blast a nuclear weapon, like Kim Jong-un or someone like that, right? The threat here is not AI. When it comes to these kind of things, the truth is that intelligence agencies, governments, they're not going to allow some automated system, I think, to take over. So it's kind of they have very strong guardrails, actually. In some of these Department of Defense and other agencies, you can't access the internet even. To get into the internet, you have to follow very strong protocols, and the Ethernet and all of that is extremely secure. So even like normal technologies are extremely secure, or treated in an extremely secure fashion in these kinds of agencies that could pose an existential threat. Now, I am actually a fan of Elon Musk, myself. And it's interesting what you said, that, the parents are telling their kids, go become techies and then you become Elon Musk. I don't think Elon Musk himself would agree with that. He would probably not say that you should go and become a techie, because Elon Musk was not trained in, for example, how to build cars, right? I mean, he didn't get a degree in mechanical engineering. He didn't get a degree in aerospace engineering, yet he's done SpaceX, he's done Tesla, right? And he's originally got his money in PayPal, but he wasn't the one who went in and coded up PayPal and did all of that. There were other people who did that, right? So I think that entrepreneurship, to learn tech skills is not the same as being an entrepreneur. The truth is that, in fact, I would argue that because of ChatGPT and all these tools, the true entrepreneurs who were previously dependent on software engineers, they had to, it wasn't unusual. I don't know if you're aware of cases like that, but I've seen so many cases in the last 4 or 5 years before the ChatGPT, where there would be a CEO or a co-founder or a founder of a company. And the CEO would usually be from an MBA or some kind of, or may not even have a degree, may have dropped out of college, like Mark Zuckerberg, but had a great idea. And, based on that idea, needed a co-founder, someone who could implement the software, right? So this would be like a CTO or someone like an engineer would actually implement the software, and they had to go to the engineering schools and actually find that engineer who would implement and take some equity in return. Well, now they may not need that anymore. I think that's a good thing. If you have a great idea, you don't need the techie anymore. You don't need the software engineer anymore. ChatGPT will fulfill your vision for you. If you have a good vision and you know how to talk to customers and you have all of those skills, and these are not techie skills, these are skills understanding your customer. It is negatively correlated with technology skills. I mean, engineers are really terrible at going and talking to real people and customers. I'm sorry to say this. I try to enforce this in my own group, where I force them. I tell them, no, you have to go and talk about your research to this other person who does not know anything. about your research. And they're like, well, it's too complicated, it's jargony. I'm like, no, try, do it 5 times and we will make it so that it's not jargony. But you have to learn how to talk to other people and different levels of expertise. So you have to go and talk to your customers. You have to have a great idea. You have to learn how to pivot. You have to be nimble. You have to break, fail, innovate, find what the world is looking for. Tech used to only be like an implementation component of that, and now that's gone away. I say good riddance. As someone who has been in technology, I want all technologists to be out of a job. It's horrible to say it, but why should they have a job? They have a skill, and that skill is automated. The world will become a lot more productive if everyone can do that, if they are not the gatekeepers of that technology. So, harsh message, find a different skill or find a way to make yourself more valuable, because your software engineering skills are not useful anymore. And if they are, then in a year, they will not be useful anymore. So, so much for, I know how to code and I'm so good at math and science and so on. I'm like, no, there is more to life than that. There is talking to people and having ideas. And we have underestimated those things for far too long. And so I say good riddance.
Oh, wow. So I
don't hear that from anyone.
Yeah, exactly. So
I come from an entrepreneurial family. That's why I can give you this harsh message, because I am not coming from one of those families where my parents pushed me that go and get great grades and all of that. I come from a family. I'm Indian, right? So I grew up in Calcutta. I spent 18, 19 years of my life in Calcutta. I went to a very good high school, academically brilliant high school. Most of my friends went to IIT and so on and so forth. And they are still my friends. But what I can tell you is, I thank God, right? And I really want your audience to get this message that, my parents were not so concerned about me being number one or anything like that. They were like, if you're in the top 10%, you're fine, which is very non-Indian like, by the way, right? We still have this obsession. We have to be number one, number 2.1% gap will get you or not get you into IIT. They were like, you know what? You'll survive. You'll do okay. You'll figure out your skills. We don't care as long as you're good. You don't have to be the best. But whenever there's a wedding in the family, and whenever there's someone coming to the house, and whenever someone is talking to you, we don't care if you have an exam on the next day. You are coming with us. You're going to get dressed, and you're going to go, and you're going to smooth, and you're going to talk to people, and you're going to be social, and we don't care how tired you are and how you are. And I cannot tell you how useful that skill is. Today, when I fundraise, right? There are so many occasions when I've just got off a flight. It's a 10-hour flight. I was just in Spain last week. It's a 5-hour flight. You're horribly tired. Sometimes you're ill. Sometimes you're just drained. You have no energy. You're struggling. You can't, think. But because when you have that training, you can go and take on the world. And you're like, you know what? I can do this. I have the training. I have the discipline. I've done this throughout my childhood. And so if you ask me to go and talk to someone and be nice and be polite and be social and fundraise and tell people what I'm doing and why they should give me money and all of that, I can do that in the middle of the night. So I think we need to get those skills back, which we used to have once upon a time. We placed a premium on all of that. And now it's all about learn how to code. So I say it's good riddance.
Right. Thank you for the message, Mayank. Harsh, but fact, and is the truth. You drilled it down so nicely. My last question to you, artificial general intelligence. There are a lot of people working on artificial general intelligence, and they're trying to figure out what could be the approach to it. Do you have like a rough understanding of what could be that approach, which could lead to artificial intelligence? And maybe who are the peers who are doing it right?
So there are so many, not so many, but there are 2 or 3 rival schools of thought, right, on this. On the one hand, there are the hardcore machine learning people, right? And so these are, I'm thinking about the original RL, reinforcement learning people, who came out with the textbook. I think Richard Sutton, if I'm not mistaken, he came out with a paper saying that feedback or reward is all reward is basically everything. Like if you can just frame everything as an RL problem, then, you can really solve it. In some sense, he has been vindicated in the sense that ChatGPT combined reinforcement learning with the transformer model. The pure transformer model turned out to be limited. And all the models before ChatGPT used the transformer and bigger transformers, but they didn't have reinforcement learning. What ChatGPT showed was that if you take human feedback and combine reinforcement learning in a certain way with the transformer, the large language models, then suddenly you get this thing that is now ChatGPT. And so there's that school of thought, which is that it's all machine learning, it's all deep learning, some kind of architecture that would be even better than transformers. So Jeff Hinton, I believe, is working on capsule networks, which is another kind of neural network. Because if you look at the history of neural networks, it's kind of been, I don't want to say accidental, but the architectures are, they almost seem a little bit arbitrary. And what I mean by that is that the CNN, that was a certain kind of architecture. There was the RNN, LSTMs, transformers, graph convolutional networks, and now the transformer with the RL and so on. So when you look at all of these models, they're all neural networks, but they have different architectures and different intuitions behind them. So for all we know, there's another one coming up, a few years from now that will be that will supersede the transformer in some way. It's possible. So that's one school of thought that, that on the one hand, maybe it's all reinforcement learning and that's all we need, or we just need a new kind of neural network, and fewer people truly believe this, is that if the model just gets bigger, the current model, if it just gets more and more parameters that companies are working on, then it gets closer to AGI. But the people don't really believe that as much as they used to. Now there's some findings that are showing that actually maybe big model is not all that necessary, that you can teach the small model. It's still transformer, still big. It's not like small as in tiny, but it's much smaller than the biggest models. And you can actually, if you train that smaller model in a certain way, then you can make it do what the big model is doing. There were major findings out of Stanford, for example, that did just that. That was limited, but it was very promising what they managed to do. And so it's not so clear that bigger is better. I mean, bigger is better, but it's not the better, the how much better is kind of controversial. And we have this instinct that we haven't exploited the smaller models enough, that there's still much more room to go. And as we learn more, the models will get better, even with the same capacity. So there's all of that line of work, right? There's that line of work. But then there's another line of work into which I fall, that I believe in, and that a lot of other peers also believe in with me, which is that there has to be a symbolic element to this, that it should not all be neural. And so we call it neurosymbolic reasoning. So that is one kind of phrase for it. And Tom Mitchell and some others who are really big in AI have been working on this. They've come out with some papers on this. But the idea is that we do need something like logical thinking, and we do need symbolic reasoning, but we don't have to go back to the expert systems and the logic-based reasoning. We are still very much in the neural framework, but we need some explicit representation of knowledge, of logic, of symbolic elements of cognition inside the architecture, to be inside the intelligent architecture, to be able to get AGI. So there's a neurosymbolic camp. And then, I would say those are the two big camps, actually. I mean, there are probably some smaller camps as well, but those are the two big ones that I'm aware of. And they're not, it's not that they are incompatible. They might still both get to very good results, but just in very different ways. With the neurosymbolic, right, the argument is that it will prevent hallucination if it's done correctly. And it's also more, it resembles human cognition a little bit more, because we do have symbolic knowledge inside our heads. It's not just neural processing. That might seem like the neurons might seem to be doing that, but when you look at the amygdala and the hippocampus and portions of the brain, there is literally a memory, there is a storage. We do have like symbolic knowledge in some form or the other that we are able to retrieve, we are able to associate. Over time, the knowledge might degrade. So we are also able to forget. This is a major problem with the neural camp, that they have trouble forgetting. So there are people doing research on that. How do you make neural networks forget? So we know a lot about learning, but we don't know enough about forgetting. And what we're finding out is that maybe we need to figure out how to make the neural network forget to make it more human-like, and so on. So it's very interesting times. I think there are several camps that are trying to get to that. They wouldn't call it AGI though. I think if you talk to them, they would not say we're looking for AGI. They would just say that we are trying to get the model to do better, to prevent problems like hallucination, to solve bigger, more complex problems. But in reality, if you solve those problems, then you have AGI actually, right? So, yeah.
Right. Mayank, really enjoyed the conversation. Some harsh messages, but I think whatever you said rings true with me. I think the world wants to paint any new technology, emerging technology, as something which as an existential threat. But you rightfully pointed out, what we've got to fear is the humans. It's never never the technology. It's the humans. I mean, it's the way they choose to use it. Can lead to. So do the right thing will happen. Do the wrong thing will happen. So really appreciate you taking time and being part of the podcast. And to my listeners, if you like what you see in here, then please press the subscribe button. Until next time, see you guys. Bye bye. Thank you. Really appreciate this.